This is part 2 of checking and verifying your anchor bolts, that your anchor bolts are placed correctly prior to erecting any steel. If you haven't seen the first video, make sure to watch that one also. These videos should also be helpful when placing your bolts prior to pouring or setting your building's foundation. Anyways, in the last video we covered the X and Y axis bolt dimensions. Now we need to go over the Z axis, or the elevations up and down. On small buildings, these measurements need to be really damn close. And on larger buildings, they also need to be damn close between them, but not being too far out of tolerance from one end of the building to the other. So, you know, we don't want this end to be 2 foot high or 2 inches high and this end to be 2 inches low or something. Here we're focusing on a small building. Maybe I can get into longer and larger buildings later, but if you can get this, the bigger buildings are just as simple. I prefer to use a transit because it's what I'm used to. However, laser levels have become more fashionable. They're easier to set up and use, and they're usually easier to rent as well. I'll be going over the transit method only because the laser method is pretty much the same idea, just with a little bit less work. I'll also cover how to do this without a transit slash laser, but keep in mind it's much less accurate. Set up in the middle of the building footprint and make sure you have a direct line of sight to where each column is going to attach to the floor. Using the bubble on the transit, verify that it's exactly level and plumb. Spend some time here. Over 60 foot, a slight deviation in plumbness can wind up being the better part of an inch or more. I guess this is why lasers are all the rage. Set it and forget it type of a deal. All we're trying to do here is figure out if the pad locations for the columns are within up and down tolerance. On a 60-foot wall, 1/8 of an inch is desired, and 1/4 inch is usually acceptable. On a longer building, that can be, this can be more, but we don't want everything, like I said before, down 1/4 inch down the entire length of the wall. That'll lead to problems. I'd say 1/8 of an inch to 3/16 of an inch between them, but no more than 1/2 inch from high to low throughout the entire building. Keep in mind that when you are recording the measurements, the lower the measurement on the tape or the grade rod or whatever you're using means the higher the pad is. If you're recording 3 foot on one pad and the next is 2 foot and 11 3/4 inches, it's actually 1/4 of an inch higher than the 3 foot pad. And if it's 3 foot and 1/2 inch, it's actually 1/2 inch low. If we're out of tolerance, we need to shim all of the low columns up to the high ones. Up to 1/2 inch is acceptable. If you need more than that, give us a call. Grouting may be necessary or something else. Don't worry, grouting is typical on construction projects like these, but you should reach out so that we can go over it with you and maybe get engineering involved if it's something way out of tolerance. The biggest concern with raising columns more than 1/2 inch or so is that we may not have enough bolt sticking through the base plate for the nut to grab onto. Also, in extreme cases, we can wind up with sheeting and trim fitting inaccurately. However, this is when we're dealing with a couple of inches, so it's pretty rare. We do have the ability to ship shims that are exact replicas of the base plate, up to 3/4 of an inch thick and as thin as 1/8 of an inch. Shipping can cost quite a bit, but we have done it before, and if you can tell us exactly what thickness you need for each location, it may make sense, and it sure is easy. It just, you just have to wait. If everything isn't within tolerance already or shimmed to tolerance, you can wind up with misfitting trim and roofs that look like they're bulging or sagging between the frame lines. I've been on many job sites for warranty work just to find out that the columns weren't shimmed when they should have been. This is why we're making the video. We want your building to look and just be something that you're proud of. And skipping these small steps at the beginning can just lampoon the finished look of any building. Okay, I know my customers. Hey Eric, I can tell it's level enough and I'm not going to buy or rent a transit laser, and I don't feel like doing that work. Fair enough. If your building is small enough, and this is not advised, but you can set up your columns, install your girts, and check the elevations with a long level placed on the girt, and then shim as necessary. Keep in mind that girts are not there to support any vertical loads. The eave struts and rake angles are actually what supports the weight of the wall. And simply speaking, girts are only there for wind loads. This means that they can sag in the middle, especially on wider spans. To correct for this, run a string line down the length of the girth at the web, and then cut some of the dunnage from shipping or a 2x4 or whatever to the exact length to place underneath the girth to force it perfectly straight. Keep in mind, this is hands down the most inaccurate way to verify your pads are level, but it is easy, and if the building lengths and widths are short enough, it is a reasonable way to do it. You can then use a big pry bar to lift up any low columns and hammer shims under as needed. One last thought before I leave. It is always better to bring low columns up, but you may find that you just have to bring something down. If necessary, that may mean you need to grind some high areas. This is up to you, and as I've already mentioned, give us a call if you're unsure. All right, I'm on to the next video where I'm going to go over some ways to correct for misplaced bolts, and that'll actually wrap up the anchor bolt videos. Then we'll get into setting some steel probably next week. Build great, and I'll see you next time.